Welcome to our Twitch viewers. We've been streaming Cosmology segments live lately, and we're continuing on with that today. So today's Cosmology segment is going to feature some interesting stuff. We're going to head into the subatomic world for a quick moment. But first, I'd invite everybody to check out our own website, smAshomash.org, smAshomash.com, and all of the links therein. Today's featured Cosmology segment product is the Condensed Matter t-shirt. So this one, if you actually click on Smash Store here, we've got actually 3 merch shops: smAsho Merch, smAsho Store, and Smash Store. This is Smash Store. And if you check out the featured products here, they're largely astronomy cosmology based. Today's product is the Condensed Matter shirt, which is incredibly high resolution, by the way. In purple, yes, Team Purple. Shout out to Veloshop, theveloshop.net. And let's talk leptons. There are 3 kinds: electron, muon, and tau, as well as the neutrinos, electron, muon, and tau neutrinos, and of course antiparticles, leptons. If you don't know about them, I don't know, have a read. So electrons and muons are what we're going to be talking about, and muons are coming up on the list. So a muon is a bit like an electron, except with more mass, and the way this fits into the standard model is, well, under dispute currently. So I'll just let this scroll for a quick moment here. Muons, they're relatively non-interactive, folks, and they're detectable thousands of meters below the Earth's surface. And without continuing on with that, let's talk more about muons. But before we do that, I would invite everybody to check out Unziger's Real Physics. So here's a little dissertation Unziger did here about why particle physics is stuck in a dead end. Perhaps check this one out. Also, check out his video on alpha decay. Alpha decay is a very strange thing, folks. And when you realize what neutrons do when they're hanging out, when neutrons are bored, they do strange things, and I won't get into it, but here's a quote.
Fourth quark generation and so on. Many black holes, extra dimensions, gravity in your face.
Gravity in your face. And so we've got 2 conflicting results here about muons. Does the muon's magnetic spin moment fit just fine into the standard model of physics, or does it not? We've got 2 articles from the same publisher, SciTech Daily, who is going the extra mile once again to show us the conflicting data here. So here is an article about how at Brookhaven they've proven that the muon fits perfectly into the standard model in terms of the precession of its magnetic spin moment. You can't make this stuff up, folks. And guess what? Here's another result showing that it's well off, as resulted by the Fermilab, well off of the the standard model. Another article on the same publisher. So this should be interesting as this plays out, or doesn't play out, or just leads to more confusion. As we've been saying for a few years on the channel, physics is being rewritten before your very eyes, folks. And anyway, a muon is 200 times as massive as its cousin, the electron. And without getting too in-depth into this, since it's a cosmology segment, check out the article. You can find both of those on scitechdaily.com. scitechdaily.com. All right, and let's continue on here. There's nothing random about Cygnus X-3. We talked about it earlier, the star Deneb, which just happens to be the brightest intrinsic object visible from our solar system. It puts out X-rays, and it's one of the only known cosmic ray point sources. But in any case, here are the X-ray outputs of Cygnus X-3, the star Deneb. And it's actually in an X-ray loud state right now. We saw, as a result of this emission right here, we saw the entire graph get expanded. Here's the 30-day graph, and you can see, again, it is in an X-ray loud state right now. We would be delighted if LOFAR would take a look at this. Hey, LOFAR, if you're watching the video, please fix your radio telescope on Deneb during its X-ray loud state. Anyway, here's the 16-year chart of Deneb's outputs. And I won't say anything else about the cyclicity, periodicity, and importance of this particular star, but if you'd like to read all about it, head to smAshomash.com/forum. There's a whole forum thread in the Cosmology forum about Cygnus X-3, which is also a celestial pole star at the other end of the precessional cycle of Earth's axial tilt wobble. And let's talk about Mars Perseverance. Mars Perseverance is about to fly its helicopter, folks. It's going to be a good time. And in the process of preparing to do so, it's taken 62 pictures. It's had 62 pictures taken. And if you want to check out this article, it's on space.com, which is basically NASA's... Let me refresh this. It's basically NASA's website. How could it be basically NASA's website? Anyway, here are some imagery. Here are some images. Here is some imagery. From Perseverance rover's selfies. And these were stitched together by a citizen scientist here. And there's a close-up of the helicopter, which should be taking a flight soon. It's got giant blades because the atmosphere of Mars is extremely diffuse. It's very lightweight, and its solar panels are a go. Let's talk about LOFAR. LOFAR is a telescope consisting of about 70,000 radio antennae across Europe. And they've done a massive survey of old galaxies. And we're seeing some incredibly interesting features, such as these. Massive astrophysical jets located at billions of light years distance. Radio telescope LOFAR reveals thousands of star-forming galaxies. And I won't get into whether or not these are really, quote, star-forming and, quote, galaxies or not. I'll just show you the fantastic imagery. Here's a massive radio source believed to be a, quote, black hole, end quote. As we try not to offend anybody when it comes to the realm of science, which becomes more and more difficult as more stuff is understood. Anyway, these are the locations of LOFAR. If you're not familiar with LOFAR, again, it's 70,000 ground-based radio antennae located in Europe. It's the low-frequency array, and it's a massive, massive radio telescope connected by a fiber optic network. This one appears to have a partial moat around it. Seems like a good idea. I don't see a drawbridge, though, so it looks like it's still in its construction stages. You can read all about it at astron.nl/telescopes/LOFAR. And that's today's Cosmology segment. Thanks to our Twitch viewers, etc. Again, I've been your host, Dan, a.k.a. smAsho. Wherever you viewed the video, don't forget to press like and subscribe. Leave us a comment. And again, please share the channel with your friends, foes, science noobs, and science pros. Let's continue on, as there's more stuff to cover, like electron flux. And we're seeing pretty low levels here. Here's the one-year chart as reported by Solon.info. Here's a 3-day chart of the greater than or equal to 2 mega electron volt electron flux as measured by the GO-16. No surprise there, we see a coronal hole wind stream happening. Here's the forecast. We're expecting an uptick, and I would expect a little higher uptick than what this forecast has, I'll say, there. The green boxes are the forecast, and the yellow diamonds are the observation. Here's a diagram of the Van Allen belts. Feel free to pause if you must. Here's the total electron content forecast. And we can expect to see some very chaotic electron flux here, actually. Some sudden bending of the bands, folks. The Van Allen belts saw a bend happen. I'll let it play through again. Right here, We see a very high level of electron flux in the central Atlantic Ocean off the west coast of Africa, right around this area. And then it suddenly shifts north. It's all a result of the North Atlantic anomaly, folks. In any case, continuing on, and by the way, we do typically see more chaotic electron belts during times of coronal hole wind streams. And I won't further elaborate on that. I don't want to give away too much of the astrophysics in any one video, because we want you to watch the other videos as well. Here's a diagram of the atmosphere, showing you things like the troposphere, where all your weather occurs, and so on. And I've forgotten to shut down the cosmology segment. See you later, Twitch.